Hi, this is Shui Liang, and doing a probability and stochastic processes homework 8, and my net ID is in sl5352. The first question here gives an xt, so white and stationary processes with an exponential of xt equals to eta, which is a constant, and the correlation, the autocorrelation of a t1 and t2 is only a matter of the difference with time. So let y be the differentiate of x, denoted as an x prime. So first things first, to find the expectation of a y. That is to find the expectation of the differential of the x. So we write it here as um, the, um, the main square sense of that kind of definition on limitation and differentiate, which is an xt plus some very little integers of a t and minus xt over the very little fraction of a delta t. When a when a t is approached to 0, that is not a very using the definition on the continuous on the random processes, and here we could to get the expectation of a y, we could just get the expectation of the whole things in our row here, right here, and then we could to exchange the sequence of the computation, which is to compute the expectation first, and then to compute the limitation, and that is here. We could get not that here the expectation is changed. No. I'm sorry. The limitation is changed to the original kind of like the very basic definition of limitation, because uh, it is a number now, so it's not a random processes. So change to the very normal limitation, and an expectation of this xt plus the delta t goes to the mean of the next time, that's a little period fraction, and to minus this one to over the delta t, which is very easy to compute. That is the derivative of um, derivative of an x expectation at that time. So given the x expectation is always a constant, so here we could get the yt's expectation is always 0. Yes, so that's for question 1. And question number 2 is to find the expectation of xt times yt, which is still the same. We write it here as xt times blah blah blah, and so on and so forth. And also we need to change the sequence of a computation, which is a limitation on the first sense, and the expectation on the first sense and limitation on the second sense. So we could acquire the correlation of the first time, which is an xt and xt plus delta t, and next time is an autocorrelation, and the autocorrelation of a different time and over delta t, which is also the definition of a derivative of xt correlation of t, and it could be written as a partial derivative. Let's just make no difference. So at this time, the xt is a white sense stationary processes, which means that the autocorrelation is also only the concern of a difference of a time, and that is tau. Here we could still write it here as this one, right? So the partial derivative goes to maybe 0. I'm thinking about it, but anyway, just you could still write it as a derivative of that. Oh my God! If it's 0, then the first, then the second, then the third question goes to the. Oh, it should be 0. So the 0 means that the expected value of x times y is 0. And given that the expectation of a y is 0, so x, y are correlated and orthogonal. This could be, just deducted very easily. That is probably the first question. And what I write here is wrong, so just ignore it.